Good morning, dear students, and welcome back. Today, for 10 minutes, we will talk about electric charges and current. This is an introduction topic for your Grade 8 Science Module 5 for the first quarter. Let's pull up your module for a quick look. Module 5 focuses on this, in further relationship between current and voltage. We will try to cover as briefly as possible all the prerequisite knowledge for the jump to voltage and current to be somehow possible. We will look at some background for the terms being used. Then we'll look at charges and current. Let's begin. When early philosophers tried being scientific and explaining their observation of this phenomenon, in which, when a certain object is rubbed with cloth, the two would tend to attract one another. If each one is placed close to bits of paper or dust, they tend to move toward the material, as you can see here. As far as thousands of years ago, they already started conceptualizing that when two certain types of materials, insulators in this example, are rubbed together, something is transferred from one to the other that creates this effect. From here, you can associate the idea of positive and negative, one that gains and the other one that loses something in the exchange. Without knowledge yet during that time of subatomic particles, they correctly inferred already that something there is transferred to the other. And this was the reason, they concluded, for this strange property that they observed. If each one is placed close to bits of paper, they tend to charge toward the material, as you can see here. So there, the origin of the word charge. And do you recognize this material here? That's amber, a fossilized tree sap or resin. This was called electrum in classical Latin or electron in Greek. So in that short period, you caught some perspective on the following terms that we will use in this lecture. The first one, positive and negative. Second one, charge and electron. This should tell you that there is a lot of science behind this lesson, which actually covers more than a millennium to evolve to the knowledge that we have today. We will just skim through the surface, and you are supposed to go deeper. You want to know more? Then get to grade 9. Want more? Get to grade 12, and probably go into STEM. Until then, we will study charges based on some conventions that we can easily understand. Here are some conventions and definitions to start with. Let's look at charges. Charge, this is a property that is responsible for electric and electromagnetic interactions. Protons are subatomic particles, meaning they are inside the atom and they are positively charged, while electrons are also subatomic particles and they are negatively charged. Anything that has zero total charge is called neutral. Take a look at this illustration. It has two positive charges and two negative charges. That totals to 0. If you rub two insulators together, say this amber and cloth, initially you have a net charge of 0 on both. After rubbing the two together, the two electrons of the cloth are transferred to the amber. Now take a look. The net charge of the amber is -2, while the net charge of the cloth is +2. What is illustrated here is what you call the law of conservation of charge. In a closed system, whatever is lost by one must have been gained by the other. You will know more about this in the future when you choose to enroll in more science subjects. Now, if you put them close together, they will attract one another. This phenomenon is an illustration of the law of charges, which says opposite charges attract while same charges repel. Now get your Module 5 and let's study some of the examples there. The first one is this. This is not illustrated as an atom, but it tells you that it has 6 positive charges and 6 negative charges. Using some algebra to assess the balance, it will look like +6 plus -6. That is 0. Therefore, this object is neutral. Let's take a look at the second one. This one has 8 positive charges and 6 negative charges. That is +8 plus -6. This gives you +2. The net charge then is +2. So you can say the object is positively charged. Okay, last one. This one has 6 positive charges and 9 negative charges. That is positive 6 plus negative 9. That results to negative 3. So you say the net charge is negative 3. The object is negatively charged. That's easy peasy, right? Let's try another set, but this time you do it on your own pace. I will show the illustration and try to fill in the blanks. You may pause the video to keep your pace. Did you get everything correct and fast? I hope so. If there are questions about this, do not hesitate to ask during the consultation period. Before we continue, recognize that in the past couple of minutes, we look at examples where electrons can be taken away or added. And if this process makes an imbalance in the number of protons and electrons, then you have a charged object. Are we done? Not yet. Unless we know the difference between an insulator and a conductor, we will not really understand electricity. Let's take a look at what a current is. There are 2 types of materials that we will look at in the way they interact with charges. Insulators do not allow charges to move in them. Examples of this are wood, plastic, rubber. On the other hand, conductors are generally metals, and they allow charges to pass through them. Best conductors are silver, copper, and gold. Just for the purpose of this analysis, let's represent these materials as these sticks, while the charges are these red circles. Charges will stay on the point of contact in insulators. Charges will distribute themselves in a metal because using the law of charges, they will repel, and conductors allow them to move. For insulators, that is not possible. They will build up on one point. What happens if we keep on adding more charges on a conductor? That is not a very significant question, unless we can give a runway or a highway for the charges to move. That is only possible if your conductor is a loop or a circuit like this. Also, we can't really add the charges manually. Instead, it will be pushed by a battery from one side, say from negative to positive. If this happens, you create a flow of charges in the wire. That flow of charges is called current or electric current. Let's wrap it up. Electric current is only possible in a conductor. Aside from that, the conductor should allow the flow of the charges, which will only happen if it is a loop or a closed circuit. To check your understanding of this concept, please answer Activity 3 on your module and check if you got it all correct using the answer key on the back page. I hope you learned something from this video lesson. I'll see you in class for your questions. Bye and thank you.